Okay, we are going to take a look at solving equations by undoing. So again, this is another review lesson of algebra. This actually is our last review lesson, so we're going to be taking a look at having a quiz coming up in the next couple class sessions. The objective of our lesson today is solving various single and multi-step equations for the indicated variable by undoing, and we're going to talk about what that really means in this video. So if you take a look at the definition of equation, the definition of an equation is a mathematical statement with an equal sign. So it has to have an equal sign. It's not an expression. It actually is going to have the goal of solving for the variable. Solving an equation is the process of isolating the variable to find its value or values. So if you remember, the square root of 16 may have more than one value. It could be x equals 4 or x equals, positive 4. So when we take the square root of a number, if x ends up being, the square root of 16, then we can say that that has two values actually, not just one. So in the next section of your notes, there are 4 steps that we're going to go through for solving equations. If we take a look at this first equation that we have, this is the equation that we're going to walk through step by step. Combine any like terms that are on the same side of the equal sign. So in order to combine things that are alike, they have to either, be alike, meaning that they both have variables like these two, or they have to be constants, which those are the terms that do not have. So let's go ahead and combine what we can. On the left side, it looks like we're going to end up with negative 2x, because 2x minus 4x is negative 2x. And on the right, I'm just going to step aside over here and real quickly distribute that 4. Okay, if I distribute the 4 to the x and to the 3, I end up with 4x plus 12, and then I see that I have a negative 2x. Well, that means that I can combine this and this, right? Those are both variable terms. And so on the right-hand side of my equation, I'm going to say 2x plus 12. And that leads me to my next step. If you take a look, we have that equation, right? So from here, we move to the next step, and we want to combine any like terms that are on opposite sides of the equal sign. Well, we already did the same side as our first step. Things that are on the opposite side, looks like we have a negative 2x on the left and a positive 2x on the right. And basically want to find a way to get rid of our 2x on the right, and basically that's just going to be negative 2x, subtracting 2x on both sides. If I do that, this is gone, right? We don't have that term anymore. And so negative 4x is going to equal 12. Negative 2x minus 2x is negative 4x. So again, if you're having trouble realizing about the negatives, that's something that you need to go back to one of our previous lessons when we add two negative values. Okay, or you could consider that subtracting a negative from a negative, that's going to be still a negative. It's important to remember that. So now I have negative 4x equals 12. So our first step we did, we have our second step completed, and now we're moving on to step number 3, which is isolate the variable term. So taking it from negative 4x equals 12, we do have the term isolated, but we finally need to get it so that we can get the x itself by itself. So after combining all like terms, you should have the variable term isolated on one side of the equation, one side of the equal sign. If it looked like this, it's still okay. The variable can be on the right. Sometimes that makes us uncomfortable, so of course we're used to it being on the left. All right, let's go on to step number 4. Solve the equation for the variable by undoing the coefficient or the operation on the variable. Well, in this case, we have negative 4 times x equals 12. What is the undoing of multiplication? Well, it looks like right here it says multiplication and division undo each other. Okay? Addition and subtraction undo each other. And we're going to take a look at fractional coefficients in a couple of the example problems, and how reciprocal fraction coefficient will help us undo a fractional coefficient. All right, so if we have a multiplication here, we have to actually divide, right, to get rid of this negative 4. Negative 4 over negative 4 is just 1. If we divide on the left, we have to divide on the right, and therefore we end up with an answer of x equals negative 3. Remember, a positive value divided by a negative ends up being a negative. So x is negative 3 is our final answer. There is some space down here at the bottom of the page in case you have questions about anything on this page. Make sure that you use the space here, and I will be asking if you have any questions when you come to class. On the back side of your paper, there are some example problems that I would like to work through with you, and then of course we have the practice problems that you're going to be doing on your own. And let's take a look at problem A. The first thing we want to do is do what we can to distribute. Okay, so on this one I have a 5x minus 10. Remember, we have to multiply the 5 times the negative 2 equals 3x minus 8. Okay, is there anything we can combine on the same side? So the first step would be same side combination, combining things that are alike. There's nothing on the same side, so let's move to the next step, which would be on opposite sides. What can we combine, to get everything to one side? Well, it looks like I have a 3x right here, and I'm going to want to get rid of that 3x over on the right, and therefore I can subtract 3x from both sides. That gives me a 2x minus 10. And I still have to do opposite sides because it looks like I have a couple of terms with no variable. So it looks like I have a negative 10 and a negative 8 that can be combined together. And in order to combine them, I have to do the opposite. If this is a negative 10, I want to add 10. And I have to do that to both sides. So 2x, and now this term here is gone, and that's going to equal 2. Negative 8 plus 10 is 2. And undoing the multiplication that I have right here, so this is 2 times x, undoing that just means to divide, so that I end up with x equals 1. Okay, up next I would like you to write this down, because for part B, or problem B, we see that we have a fractional coefficient, that's 3 over 4. To undo, remember undoing is doing the opposite of it, so we have to undo the fraction. So that means we're going to take the reciprocal, that's just flipping the fraction over. So flip the fraction and multiply both sides by the reciprocal. So on the left, I'm going to multiply by 4/3. Okay, so I'm going to multiply the left side by 4/3. And if I multiply the left side by 4/3, then I also have to multiply the right side by 4/3. Okay, so this is my reciprocal right here. It's the flip of the coefficient 3/4. And basically that takes care of getting x by itself. I just have x here. The 4 times 3 over 4 times 3 is just 1. So I have x on the left, and I can multiply negative 21 times 4. That's going to be negative 84 over 3. And if I divide 3 into negative 84 using my calculator, I get negative 28. Remember, this negative 21 is over 1. Okay, so any whole number is over 1, so that makes it easy for me to multiply across the top, multiply across the denominator, and that gave me my negative 18 over 3. Of course, that's just a division problem, and so there's my answer. So be careful when you see the fractional coefficient. There are a couple problems that you're going to need to do. Remember to take the reciprocal. Let's go ahead and move on to problem C. So in problem C, it looks like we have to distribute this first initial negative sign. Remember, there's really a negative 1 outside of the parentheses here, and so we just are basically changing the sign of everything inside the parentheses. All right, so if we do that, we're going to have a negative 4x and a negative 4 because we're distributing that negative to everything inside. And if I take a look at what I have, it looks like I have a term here, it's negative 8x, and a term here, negative 4x. I want to try to get those so that they are on the same side. So if this is negative here, I have to do a positive in order to get rid of the negative, right? So I have to add 8x on both sides. That's going to cancel this term completely and give me a negative 20 here. Remember, we have to save here whatever's left. And then over here we have 4x minus 4. All right, so my next step is to get together the things that don't have variables. Okay, so I don't have a variable with these two terms. I'm going to undo the negative 4 by adding 4. Okay, that's going to cancel that term. I still have a 4x on the left, and I have a negative 16 on the right. So this negative 4x is the one that I wrote there. All right, so to undo this multiplication of 4 times x, undoing it is dividing by the coefficient there. So I should end up with x equals negative 4. Okay, the final problem that I'm going to take a look at with you is problem D. And you might have seen these problems prior to this class. Obviously, this is a review lesson. But if you can remember that this is called a proportion. Okay, so the fraction on the right, we're trying to find out what p is to make these two fractions equal. Well, the other thing that you can remember is that you can cross multiply. Okay, so cross multiplication is where we multiply the number in the denominator, p, times the number in the numerator of the other fraction, which is 7. So if I cross multiply, I get 7 times p, and that's going to be equal to 4 times 11. So we're just going to cross multiply. So 7p equals 44, and if I divide by 7, I get 44 sevenths. I could leave that answer as it is, or I can divide 7 into 44, and let's see, that would be 6, right? 7 goes into 6. No, 7 goes into 44 6 times, and that's just with 2 left over. So I could make a mixed fraction answer as 6 over 6 and 2 sevenths, or this answer of 44 sevenths is also okay. The important thing to remember here is the cross multiplication trick, and that the p, once we plug that number back in for p, we should be able to get an equal fraction to the number on the fraction on the right. The final thing for you to do is finish up the problems that you see in the On Your Own section in order to get full credit for your notes. Also, please write down any questions that you have as you're working so that you can ask those specific questions. Please make sure you show your work in this section, and have a good night.